Introduction. When do we need to work with multiple lines of information? Here we can see an example, but there's hundreds of other examples that we could imagine. For example, let's say we have a scenario where we could operate with one unique element. For example, let's say I want to do a purchase order and I want to place my order, for example, for a course, and then I want the teacher to give me the course. Once I've approved, I want it to be corrected and so on. That would be one unique request that has to be managed. But in some scenarios, this is not possible. It's much more advisable to follow a multi-element strategy, multiple lines, in which each line of a group of fields or a batch of lines of a group of fields require a specific treatment. Here we can see an example. Let's imagine a factory where we have to make furniture and we have a chair, we have a table, we have a couch, we have a shelf, and a cabinet. Let's say we could prepare all of this material. The factory could actually have this chair completed, this table completed, this couch completed, this shelf completed, and this cabinet completed, all of it done from the beginning to the end in a certain amount of hours. For example, here we can see it would take the factory 4 hours to build a chair. It would also take them 4 hours to build a table. But in this scenario, it's quite clear that the cost of preparing the machines and preparing everything for in order to manufacture these products is much higher than the manufacturing itself. So it doesn't really make sense to run a process where we're only going to build a chair. We're only going to make one chair. Why? Because the preparation time here, let's say we have to prepare the machine. We have to, maybe there's drills that have to make holes in the chair. Maybe we have to prepare a certain saw in order to cut the chair, cut the wood to make the chair. So the total amount of time to create the chair is actually 4 hours, but the preparation time is 3 hours. This is 75% of the time is invested in preparation. So let's imagine if instead of doing this, we say, okay, we're not going to prepare one chair. We'll wait, and once we have a batch of 100 chairs or 10 chairs or 1,000 chairs, then we're going to make these chairs. It would make much more sense because let's say the preparation time of preparing the saw, of preparing the drill, and so on is going to be exactly the same if the factory has to make one chair or 1,000 chairs because the preparation is exactly the same. So why would we spend so much time in preparation to make one unique chair? In this example that I'm trying to explain, it would make much more sense to create a batch, to say, okay, I'm not going to manufacture anything until I have a certain amount of chairs. This time, the production, the costs are going to be much lower. So as it says here, in these cases, it's obvious it makes much more sense to create larger production batches in order to invest much less time in the preparation phase. And obviously this is going to allow us to build chairs with a much lower cost. It's going to avoid bottlenecks and so on. So we already know that a group of fields is composed of columns and rows. The rows are homogeneous informative elements that are used in processes, either as elements or as batches that match a certain condition. This is what we call a container. So let's say, for example, all the lines that in the column wash say yes, let's drop them into the container wash. All the lines that in the column cut say yes, we can drop them in the container cut. All the lines that have yes in the column die, we can add them to the container die and so on. Okay, so we can create batches, we can create sets of information with all of these rows that meet these conditions. Now the lines that need to be processed are going to go through threads of a process. These lines could be clients, products, solutions, pieces, files, or in this example, customers who need to go to the hairdresser in order to get their hair washed, cut, dyed, or whatever. Okay? Now, these lines can travel through all or part of the process, and they can be processed one by one, or they could also be processed in batches. Each line is going to receive a specific treatment. Therefore, it's going to undergo a sequence of activities throughout the process. For example, Ian, who needs to wash his hair, to cut it, to dye it, well, he doesn't need to dye it. Well, then it's only going to, this line is only going to suffer or it's only going to experience certain specific treatments. the treatment is going to be washing the hair and cutting the hair. But then there's other lines, other items in the process that are going to experience a totally different treatment. Now, this is going to be the corresponding treatment according to the information that we have in each line. So based on the information of each line, we can design a process to redirect the flow and to send each line where it has to go. Here we can see an example. Let's say we have all these lines and they're going to enter this process. Now we want to give each one of these lines a specific treatment. Once they've been processed, the process is going to end. So let's say we have Ian. He requested a wash and a cut. So he wants to wash his hair and he wants to cut his hair. He doesn't want anything else. How's the flow going to work in this scenario? The flow is going to enter the start message event with his request. It's going to go to the person who needs to wash his hair. And after that, they're going to send him to someone else who can cut his hair. And then the process is going to end. What happens with Fatima? She's going to experience a totally different flow in this process. Here we can see she wanted her hair washed. She did not want it cut, so the flow went this other way. She did want it dyed, and she also wanted a hairstyle. Okay, so this is the experience of Fatima, but then Sarah has a totally different experience, and Anna has a totally different experience. So depending on the data that we have in each line, we can offer a totally different experience to these lines. Now, we already know this is achieved using containers, but in some scenarios, in more complex scenarios, we might need to apply this treatment in different classes of process. So let's say we have all kinds of different classes of processes, and we have different treatments that need to be applied to the lines in all these different classes of processes. So a procedure that includes complex distributed treatments usually involves the intervention of more than one process. So here we have a scenario where one line travels like this. So the procedure must follow the life cycle of each line created in the group of fields. So for each line, we're going to have a different procedure. It's going to be deviated to different processes. And this way, each line is going to receive its specific treatment. Here you can see this line. It travels in a certain direction from one process to another one. It receives a certain treatment. This one receives a totally different treatment. And this one too. Okay. Now, each line is going to travel through a number of processes, which is going to provide all the necessary treatments until the life cycle of that line reaches its end. Obviously, you guys have been studying throughout these previous courses. You guys have learned how to use containers. You guys have learned how to use transfers, uploads, and all kinds of other automations for the data that we have in a process. And here, we're not really learning any new concept. We're not learning any new features, sorry, but we are learning how to combine different features in order to achieve a certain solution. So obviously this is an advanced course. We're practically finishing the course. So it's very important to make sure that you as a student can combine all of these features and come up with a solution like the one we're trying to explain now.